planets outside our solar system, the vast majority are gas giants, which are easier to find than small terrestrial planets like our Earth.
To build instruments to analyze those Earth-like planets, we have to anticipate ahead of time what the chemicals might be in that Earth-like atmosphere. For that reason, we need theory, we need models.
Victoria Meadows is in the planet modeling business. She heads up the Virtual Planet Laboratory at Seattle.
How many of those stars have planets? How many of those planets are close enough to have water? And on and on.
That's a problem that astronomers Carl Sagan and Frank Drake took on decades ago. Drake came up with an equation that estimated that up to 1 million civilizations may exist in just our Milky Way alone.
The Drake equation is this series of numbers that are trying to be put together in such a way to give us a kind of way of even closely estimating how many other intelligent civilizations are out there.
Peter Ward, a professor of biology and geology at Seattle's University of Washington, thinks the Drake equation greatly overestimates the number of advanced civilizations that could exist on other Earths in the universe. Ward and astronomy professor Don Brownlee's book, Rare Earth, explains why they think complex life, animal life like humans, may be rare in the universe.
We began to think that it was just too simplistic, that there's other stuff involved.
Ward cites a number of factors that he thinks would lower the original Drake estimates of how much complex life could exist in the Milky Way, and by extension, the universe.
First of all, plate tectonics. Plate tectonics is continental drift, and one wonders why would that have anything to do with the frequency of life on the planet? Plate tectonics also produces a recycling of elements. And that recycling does some very fundamental things. The most fundamental thing it does, it produces a temperature gauge. It's like a thermostat on the planet.